Okay, so we're looking at the quadratic formula. And first we're going to look at where did it come from. Everybody likes to say, like, when something's annoying in math, like, who thought this up? Who created this? Why did they do this to us? And contrary to popular opinion, the quadratic formula was not created to torture high schoolers. It was created as a shortcut to completing the square. Because completing the square is great when you have a coefficient of 1 and the b term is even. It's actually pretty quick. But when the coefficient is not 1 and then it doesn't go evenly into the b term, now we get lots of fractions. And I'm sure that mathematicians were working with it thinking there's got to be a better way. And so somebody decided they were going to take the general form of a quadratic, ax squared plus bx plus c equals 0, and they said, what happens if I complete the square on this? Wouldn't it give me a general formula where I could just plug numbers in and get an answer? And that's what the quadratic formula is. So you don't need to actually copy any of this down. Just follow along with me and kind of see if you can predict or see the developing formula, right? If we remember what the quadratic formula was. So our first step in completing the square is dividing everything by the coefficient. And so we get x squared plus b over ax plus c over a equals 0. And we can already see we've got a fractions in here, but they'll work themselves out. And then the second step was to move the constant term. So we have x squared plus b over ax. And then we're going to leave that space that we've been practicing leaving because that's how we're going to complete the square. We want to make the left side a perfect square trinomial so we can factor it and then use the square root property to solve. And so to do that, we have to take b over a and divide it by 2 and then square it. And this is where, like, now you're dividing fractions by fractions, but remember that dividing by 2, we will multiply by the reciprocal 1/2. So it's b over a times 1/2, which is b over 2a squared, which is b squared over 4a squared. We square the top, square the bottom. So here I have b squared over 4a squared. Okay. Now, this side is a perfect square. And remember, we said this is how it factors. So this is x plus b over 2a squared. And then I need to combine these two fractions. So I have negative c over a plus b squared over 4a squared. And we need to times by 4a so that we can get a common denominator. Because if I multiply a by 4a, I get 4a squared. So I end up with negative 4ac over 4a squared plus b squared over 4a squared, which if I put together and put the positive one first, the denominators are the same now. I have b squared minus 4ac over 4a squared. Do you see a part of the quadratic formula yet? And then, continuing our solving, we're going to take the square root of both sides, plus or minus the square root. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac, all divided by the square root of 4 is 2, and the square root of a squared is a, so all divided by 2a. And then I'm going to subtract my b over 2a, negative b over 2a. That should sound familiar, right? That's our vertex formula. So x equals negative b divided by 2a plus or minus the square root of b squared minus 4ac over 2a. And because they have the same denominator, I can put that all under one fraction. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's where the quadratic formula came from. So some people think it's pretty cool. Some people are like, I have no idea what you just did. But okay, that's where it came from. So this is now the shortcut to completing the square because all you have to do is plug in A, B, and C and evaluate the expression. So there's a song that goes with it. And if we were in class, we would all sing this together and it'd get stuck in your head and you would be dreaming the quadratic formula song. But I'll sing it for you once, just once. It goes to the tune of Pop Goes the Weasel. It goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so hopefully that gets just ingrained in your brain. And all day long you're singing it. And you curse me for getting that stuck in your head. So the next thing I want to look at is what the discriminant is. Discriminant. The discriminant is the part of the quadratic formula under the square root. It's b squared minus 4ac. And it determines the type and number of roots because the square root is that piece that determines whether we have real numbers, whether it comes out as a whole number, and so that part determines what our roots look like. So the discriminant is b squared minus 4ac, and we can use a big D for that. So if b squared minus 4ac is positive and a perfect square, we have two real rational roots. Roots, solutions, zeros, x-intercepts, those are all the same thing. If it's not a perfect square, we have two real irrational roots. Now, rational roots means it's going to come out like 1 in 5 or 1/3 and 2/5, something like that. Irrational means it's going to come out as like -3 plus or minus the square root of 6. If b squared minus 4ac is equal to 0, we get one real rational root. And if b squared minus 4ac is less than 0, we end up with two complex or imaginary roots. Okay, so the discriminant helps us determine what kind of roots there are. And when there's complex imaginary roots, that means it doesn't cross the x-axis. When there's one real root, it means it crosses at one point, one place. The vertex is on the x-axis. And when there's two real rational, it crosses at whole numbers or like perfect fractions, and irrational is like decimals that don't repeat. So let's do our first example. On the homework tonight, you are going to be asked to first find the discriminant. Second, determine the number and type of roots. And third, it's going to ask you to find the solutions. And once you've done the discriminant part, the quadratic formula part's a lot easier. There's a lot less mistakes you can make. So here's our first example. 5x squared plus 2x equals -1. And I always have to make sure it equals 0 before I decide what a, b, and c are. So we're going to add 1. 5x squared plus 2x plus 1 equals 0. So my a is 5, my b is 2, and my c is 1. So step 1 is find discriminant. That's b squared minus 4ac. So that's 2 squared minus 4 times a, which is 5, times c, which is 1. And remember, this is the part that's going to be underneath the radical. So once I've done that, all I have to do is put this number under the radical. So that's 4 minus 20, which is -16. So my discriminant is -16. The second part is determine number and type of roots. So our discriminant is negative. Negative is less than 0, So our two imaginary roots. That's what it means, right? From what we had on the last slide. So this means there's two imaginary or complex roots. Complex just means there's a real number somewhere with an imaginary number, like 3 plus 4i. That's complex. And then lastly, we're going to find the solutions. I don't know why I typed 4. So we're going to plug it in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I think it's a great idea to write it down with every single problem. By the end of this homework assignment, you will have it memorized if you don't have it memorized already. And so negative b, so that's negative 2, plus or minus, we already found b squared minus 4ac. That's the negative 16. That's hit this, so I'm going to put that under here, and no point in recalculating it. All over 2 times a, which is 5. And the square root of negative 16 is 4i over 10. See how we got 2, we're getting imaginary because there's I there. And then I can simplify this because I can divide both of those by the common factor of 2. So I get negative 1 plus or minus 2i over 5. And those are my two complex roots. Remember that negative 1 plus 2i over 5 is 1, and negative 1 minus 2i over 5 is the second one. Okay. Let's do one. Yeah.
Could you tell me again what was the complex root?
Complex means I have a real portion, this 1, and then I also have an imaginary together. So complex is when we put the real and the imaginary together.
Got it. All right. Thank you.
Because technically, if it's just imaginary, there's only like a number times I.
Yeah. Thank you.
So let's look at another one, 4x squared plus 3x equals negative 13x minus 16. So we need to move everything to one side. So I have 4x squared plus 16x plus 16 equals 0. And my a is 4, my b is 16, and my c is 16. Now, technically, you could divide this by 4, and you're shrinking it. But when we're asking for the discriminant, we want to make sure we get the actual discriminant for this problem, and so don't divide the numbers. So 1 was discriminant, so b squared minus 4ac. So that's 16 squared minus 4 times a, which is 4, times c, which is 16. So that's 256 minus 256, because 4 times 4 is 16. 16 times 16 is 256, and I get 0. So my discriminant is 0. Two, how many roots are there if the discriminant is 0? There's one real rational root. And our answer should confirm that. Okay, so once we find the solution, we should only be getting 1 because our discriminant is 0. Plug in 3. Number 3 is find the solutions. So that's negative b, which is 16, plus or minus the square root of b squared minus 4ac, which we found was 0, divided by 2 times a, which is 4. So that's negative 16 over 8, plus or minus 0 is just plus 0, and that's why I only get one real solution.